What's up, guys? I had made a video covering the first two sections of this unit where it just basically introduces what tuples are and what lists are. But now the second half really gets into the good stuff. What can you do with them, especially lists? Lists have so many possibilities of what you can add, rearrange, combine, find stuff. It's all really nice, powerful in terms of what you can do, and forgiving in terms of like not always requiring as much hardcore specificity as you might think. So let's get into it. The first practice is pretty simple, and it's called max in list. It's going to give you a list of numbers, and you're going to find the biggest one. Okay? So it's going to say, let's imagine you get some integers, and for this you want to return 23, which is the biggest. You don't have to say where it is. You don't have to move it to the front or anything like that. You just return that value. And yes, there is a built-in way to do that, but we're going to make our own just for practice once, and then later you can use max on its own. And keep in mind that all these guys might be negative, and if -5 is the biggest, we want to say -5 is our answer, which might be treated the same as positives, or we might have to add a little extra thing to be ready for that. We'll see. So since this is in the for loop section, we can guess that we're going to look through the list using that, and that would make sense. So let's say for, remember, we're assuming it's integers, but we don't know how many or anything like that. For each guy, we just need to see, is it the biggest ones we've seen so far? And if not, move on, it doesn't matter. But if so, we need to put it in that spot. Like you go through and you have a pedestal, and 5 is on the pedestal, 2 doesn't knock it off, -5 doesn't, 10 does, so it takes that #1 spot, and 5 is forgotten. Now 23 takes the #1 spot, and 10 is forgotten. And then at the end, we only need to know that one. We don't care about second place or anything else. So for each guy in the list, I'm going to say guy, but you can call it whatever you want to call it, in my list, and that is sent to us from outside, so our name for it is my list, and we don't change that. For each one, if it's more than the previous highest, which obviously we have to create that, then it takes the spot. So let's say we start with 5, and then this one doesn't take the spot, does. But before we do that, how do we start it? Often when you're making an integer that's going to be keeping count or keeping score or something, you could say 0, and then you just add to it. But this wouldn't work for that, because sometimes it would immediately get replaced and you'd be fine. But what if all the numbers are negative and none of them ever take the highest spot, and you'd return 0, which isn't in the list at all? So that wouldn't work. Even if you make it say -1,000,000, well, what if all the integers are less than that, and then you return something that wasn't in the list? So we have to start it out as something that is in the list, and we might as well do it as the first item. Now these aren't in order or anything, but it doesn't matter. We're going to cover them all left to right eventually. So that is kind of all we need, and then at the end we return the highest. Let's hit test and see if they like that. And they do. So if it's checking 1, 2, 3, then each time this guy replaces the previous one, this guy replaces the previous one. This time there was only one ever, and that works fine. This time they're getting lower, so it never replaces the previous one, but it making sure that we don't start at a 0 or something like that. So that one's pretty easy, and it doesn't use any fancy methods, but we'll get to some more interesting stuff soon. Let's say we're going to look at owls. This one starts us with a string instead, and it's going to say you have a text, maybe we'll call it a paragraph, that has the word owl in it several times. Okay, it says your friend likes talking about owls, and the word owl or other forms like plural or howl or something else. And we want to count how many of those. So it's not giving us a list, it's giving us a string, which is one whole thing. And we could loop through the string and like at each character we look at the next couple and see if that equals owl, but it would be a lot of trouble. What we're going to do instead is turn it into a list and also turn it into lowercase, like they say, in case there's a owl at the beginning of a sentence. And the way we're going to turn it into a list is very simple. There's a method called split. If you say some list dot split, then it will make, or some string dot split, it will make a list, breaking it at each space. So it would be like there's a space, okay, there's a new spot, really, space, there's a new spot, like, and you could tell it to look for other things like commas or periods, but by default it looks for spaces and it will use those as the border between words. So let's try it. I'm going to delete the sort of answer key there. And so we're going to say another for loop to look through the list, and if we ever see owl, then we add to the counter. But before that, we have to make the list. So our string is called text, and I could say text equals text.split. And this is a little weird because text is a string and now text is a list, and that's okay in Python. It has what they call dynamic typing, meaning you could say x equals 5 and then you could say x equals hello world and it doesn't mind the change. In some other languages, once it's an integer, it's an integer, or once it's a string, it's a string, or whatever. So you could make a new thing if you wanted, or if for whatever reason you wanted to keep that original string separate and use it later or something. You could say text list equals text.split and then go from there. So before that, we want to do the lowercase thing probably. So I'm going to go text equals text.lower. And so now we've got a list that is next thing, really, next thing, like, and they're all lower. So we can look for owl and not have to worry about case or anything like that. So let's say for word in text list, if owl in word, we do something. And what do? We're going to keep a count. So I'm going to say count plus equal 1, which means we have to start it somewhere at 0. And then we return count once we're done, not in the loop, but after the whole loop is finished. And I think that's all we need, unless I mess something up. Great. So when it says whose friend is a wise old owl, it caught it even though it had a capital. And when it said owlets and other words that have owl in there, it caught it even though it wasn't a standalone word. So that's good. But guess what? There's going to be a part 2. I always like the ones that have a part 2 because it means they're going to start you off with some basic mechanic and then add to it to make it interesting. So let's look at the owls part 2, and I'll copy the code that we just did from the previous one and add to it for the second version. And the second version says not only do you want to count how many, but you want to say where. You want to say like, oh, the first word was owl, and the 5th word was owl, and the 10th word was owl, or whatever. So we don't have to change that much. We've already made it into a list, and we're already looking through the list to find the stuff, but we just want to, at each moment that we do find something and increase the count, we want to also keep track of the index. And we could do, here's a little hint, by the way. We could do this loop needs something. This loop needs something because if I say for word and text list, we're not keeping track of the index, I could have like a separate iterator variable that's like +1 each time, and then that tracks how many times we've gone through. Or I could do I in range, and then len, and then all that stuff that I've mentioned a few times recently. But there is a better way, which is enumerate. Because sometimes you want to move through elements in a list and you just care about the elements. Sometimes you want to move through numbers and you need the numbers, but a lot of times you need both. And there is a way that's already built into Python to do both, to move through a list, keep track of where we are and what we're looking at, and that's enumerate. So it's kind of like range, but it has two things instead of just I or whatever. It's your first thing, comma, your second thing. So I'm going to call this I in word, meaning the index, and then the string that had been a lot split into separate words. But you can call these whatever you want. When you do enumerate, you can call it index and element, or I and j, or whatever. So I word in enumerate text list, and this is going to still work just fine with this thing. If I say word, it still knows what I mean. And now we need to say, if we found one, we want to do another thing, which is add I, our index, to a list where we're keeping track of where we found them. So we're going to need owl indices equals a list, and to make a list you can say list, or even shorter you can say to brackets. I could make it with stuff already in there, or I can make it with nothing and then add later. So I'm going to make it with nothing, and then whenever I do find one, I'm going to say, okay, keep track of that spot. And so I'm going to go owl indices dot append. Append just means you're adding a thing to a list. Maybe I could do plus equals and that would work just fine, but I'm going to use append I. And then for this one, instead of return, it's going to tell you to like print 2 lines that spell it out. So we're going to print there were, I'm going to use double quotes, there were how many count. That's the same as our last part 1 version. That contains owl, and then they occur 2 C's 2 R's at indices owl indices. Now I believe it says to ask the user to input. I don't know why they changed that from the last one, but it does. So let's say owl count, which is the name of our function, and we're running it with input, and then we're prompting them. Let's say tell me about owls. And then when I run this, it's gonna say that, and then we can say I am owl boy, I am an owl, and also a boy, my name is also Owly McAllerson, and then it says there were 4, and here are the spots. Now I haven't counted to see if those spots are right, but they seem like they probably would be. And let's hit the test, and guess what? They like it. So we're good. Now that was the for loop stuff, but there are other methods as well. And just to remind you, method is like a function. We've made functions ourselves, and we've used some that are already existing in Python. But method is a very similar thing where you have the name of some kind of verb and then you have parentheses. The difference is a method is attached to a class or a type, where functions can just be floating and you just run it like in the code, not attached to a certain thing. But a method is like, oh, lists have reverse or sort, strings have split or whatever, and that name difference matters, but it's also not a huge deal. If you want to think of methods as functions, that's not too bad. So let's say we're going to look at some of the, actually this practice is way too easy. I'm going to skip, because you literally just say the name of the list dot remove, the name of the list dot sort, the name of the list dot reverse. And maybe they wanted to give you an easy one at first, or maybe the person who wrote this was a Missy Elliott fan. But I'm going to skip to this part. It says librarian. So there's a part 1 and a part 2. So let's look at that. The librarian thing is taking in some names and alphabetizing them. That is not too bad, not too difficult, but we got to get it ready, and then the part 2 is going to add a complication. So it says ask for 5 and then print them in order. So we're going to say this is we're going to get the input, and then we'll sort of add lines above and below to wrap around all the stuff we need. But we know, ask the user for the last names. We can do that, you know. Enter an author's last name, and then we know it's going to be 5, exactly 5. You don't have to ask how many, it's just locked in. So we can say for I in range 5. We don't have to worry about going through a list or enumerating or anything. We'll do that later. So we're going to ask 5 times for entering an author. And now we do the list stuff. That's like, okay, how are we dealing with this? How are we arranging it? All that. But I often say, and I often stress to you guys, that you don't have to write it like top to bottom. You can write like the middle part and then bounce around and sort of get your little, like when you're making cotton candy and you have like the little stick that starts you off and then everything else whips up around it. You need that like little bit to give everything else something to hold on to. And I'm going to say we want to add them to a list every time we get this input. So let's write that. Author lists, no, author list dot append author. Now we have to bounce to the top and make that author list, and it'll start out empty, and then it'll get 5, and then after we've got all 5, we can sort it. We don't need to sort it halfway. I mean, we could sort it each time, but that would be a little bit wasteful. We can wait until we got it, and then say the thing dot sort. Okay, that was a method it showed in this. But these do exactly what you think they do, basically. Like, one of the things about lists is that they're almost too easy. Like, Python lets you put anything in there and do whatever you want with it. And sometimes you can forget the basics, and you forget, like, wait, what kind of types are we working with here? How did they get here? Because it's so, like, intuitive. Append means you're adding something. Extend means you've, like, added another list onto the list to make one super list. Sort puts it in order. Reverse flips the order. Count tells you how many of a certain thing. Remove removes a certain thing. And there are others related. For example, there's one called pop, which is like removes it and gives it to you rather than just throwing it away. So these are like really, really nice and easy to use. So we can say author list.sort, and then I think they want us to print, and then let's see how they like that. Hey, they like it. Great. So I'm going to copy this and go to the part 2 thing and see what they want in part 2, because that's when it gets good. That's when it always gets good. Part 2 is listed as challenge, so you know it must be fun, right? Librarian part 2 is going to say, hey, the way that first one worked doesn't really make sense because they were inputting just last names. But in real life, you would input the whole name most of the time, right? You would say Stephen King or, you know, William Shakespeare or whatever. And the computer's job is to like find the last name and use that for alphabetizing. But the user might not do that work. The computer's going to have to do that work. So it's going to look for the last name and then use the last name. And it might not just be exactly 2. Okay, we got Maya Angelou, Tobias Wolff, but maybe somebody has a middle name or 2 last names or hyphenated stuff. There are some Spanish names that have the mothers and the fathers and other stuff added on. There's some Arabic names that have multiple quote-unquote last names. So we're going to look for the last one. Okay, not the second one, but the last one, however far that turns out to be. And I know that's not bulletproof. That wouldn't work for every name on the planet, because some Asian names will put the family name first and then the person's name second. But for this, we're going to go to the last spot. And then we're just going to display the last ones in order like we did in the previous thing. So I'm going to delete what I had and just copy what we typed a minute ago and say, okay, we're going to need to change this to make sense. And then we could change the name of this variable to be like full name and then make a new one that's called last name. I don't know. We'll see how that goes. But we know that we're still going to make a list. And we're still going to sort and print it at the end. So whatever changes we're going to do are just in the middle. And it's still 5, by the way. So whatever we add is going to be in here. Everything else can remain unchanged. So we're going to get a similar thing to what I was saying a minute ago with the text owl thing, like changing from a string to a list. And this, we could take it string to a list and back to a string. Like I could say author equals author.split, and then I could say author equals author -1 to get the last spot, you know. And this is looking very strange, like it's the same name going through a bunch of weird processes and even going through different types. But it ends up where this is the last name, like into the full thing, okay, then split it, now it's a list, then just take the last one, okay, now it's a string again, but only the last part. But this looks really weird, and it looks kind of like there must be a better way, right? So we could do a couple things. One is we could give it a different name. We could say like author last name, because that's actually describing what it is as different from what they entered. Or we could say, hey, we only want the last name. So instantly when they type it, we're just going to split and grab the last one. So like right off the bat, we just instantly toss the first and last name. And that would work for this. Like, unless I messed it up, there's going to be green. Yeah. But whenever they do stuff like this, when there's a part 1 and part 2, you can imagine a part 3, even if they don't have it. And you can imagine that in real life, if they were getting full names and then using the last names, they'd probably want to put the first back on there eventually, right? Like if you have some authors and you're gonna order them according to the last, you still want to use the first name sometimes. You're not throwing it away. So this is totally fine for this mini universe of the question. But in real life, if I were getting input from the user and I knew that it was all important, I would like keep the first name somewhere and use the last name for now, but then be ready to throw it back on, like if I was going to display a list of books or print them as labels or whatever, right? So I would probably do it like that maybe, and then say author last name equals author -1, and then we still have author as the whole thing that we can use later, but it's already split because we know we're never going to like use the whole string all at once. We're probably going to display the names last comma first. Like what are the examples? Like we probably say Wolf comma Tobias or something. Now who knows, if you were making the big thing, you'd try something and see what happens and then go from there. But it's often nice to think about how this would work in real life and not think about what gives you the green check mark right now, because you can do a lot of goofy stuff that gives you the green check mark right now that would then make it really hard on you tomorrow, or make it really hard on the next guy who has to fix this code for, you know, replacing you in 10 years when you get a different job or something. So there you go. I'll stop this now so we don't make a super long video, but I wanted to cover a bunch of the stuff from these sections.